audio from my telephone. All right, so what problems do you have for me tonight?
I have some exponent problems that were on a previous test and I got them wrong, but I want to understand why.
Okay.
So, 4j cubed k to the fourth.
Hold it. 4k cubed.
No, j cubed.
Okay.
So 4j cubed.
In parentheses or just 4j cubed? Is it 4j in parentheses?
No,
Okay.
not parentheses.
Okay.
K to the fourth. K to the fourth. Over 6j to the ninth.
K?
K to the negative 6.
Negative 6?
Mm-hmm.
Okay. The first thing we want to tackle here is the number part. What happens to the numbers?
2/3.
Okay, the 2 stays there, the 3 stays there. What about the j's? How do you take j to the third divided by j to the ninth?
J over j to the third.
It's you subtract the exponents. So it comes out to be j to the minus sixth, which is the same as having j to the sixth in the denominator. Okay? In other words, you don't divide the exponents. You subtract them.
Okay.
Okay? And what happens when you subtract the exponents on the k?
Well, then you have to bring the k to the 6 up top.
Or we could just subtract the exponents. What's 4 minus a minus 6?
K to the negative squared.
K to the 10th. 4 minus a minus 6 is equal to 10. So k to the 10th. In other words, you can worry about whether to put it in the numerator or the denominator later, at the end of the problem. The only thing you have to do immediately is subtract the exponents. In other words, I immediately see that I have 2/3 j to the minus sixth, k to the 10th. And now I want to write that without any negative exponents, so I'm going to put the j in the denominator, and I'm going to leave the k in the numerator, and that's how I do these problems. In other words, I don't worry about whether I have a positive or negative exponent until I'm done with the problem, and then I make sure that everything's positive.
Okay.
Okay? What is this? What's this equal to?
X to the 8th.
Okay. In other words, when you're multiplying, you add the exponents. When you're dividing, you subtract the exponents.
Okay.
Okay? What else?
So parentheses, like really big, because you're going to fit the numerator and the denominator in there. Okay, so the numerator is 3ac to the negative 2.
Just the c?
Yep.
Okay.
Over negative 2a squared c cubed y.
That it?
And parentheses negative 2.
Ah. end parentheses, -2 up there.
Yep.
Okay? Well, there's only 3 rules when you're dealing with exponents. There's when you multiply, same base. There's when you divide, same base. And there's when you double exponentiate. Okay? You know, I hear audio in the background that sounds like it's your computer and not your telephone. I heard it right before you came on also. I don't know what that means, but anyway. All right. So the first thing we should do here is apply that to all of our exponents. Okay? And in fact, apply it to everything. When we apply it to the 3, we have 3 to the -2. A to the -2. See what?
C to the -4th.
+4. In other words, is all we're doing is multiplying. All we're doing is multiplying exponents. Okay, and I'm going to do it at the bottom also. -2 to the -2. And then A to the -4, because I'm multiplying -2 times 2. C to the -6. And what's the Y?
Y to the -2.
Okay. Now we can simplify. Okay. Well, the first thing that happens is this becomes 4. Oh, excuse me. -2 to the -2. Let's do another thing here. The one thing you can always do with negative exponents is to put it in the numerator. In other words, put it on the other side of the fraction bar. I can put this 3 to the -2 down here as a 3 to the +2. I can put this A to the -2 down here as an A to the 2. And I don't need to move that. That's already got a positive. So in this problem, I'm going to suggest that we change everything to positive exponents to begin with. So this becomes that. That takes care of that. What happens to that?
It goes up top.
In parentheses, we're going to make it look like that. Now, I can either switch the A's and put A squared in the denominator and A to the 4th in the numerator. That might be the easiest way to do the problem, avoiding mistakes. Okay, you see how I did that? Okay, we're going to do the same thing to the C. I'm going to leave that in the numerator because it had a positive exponent, but I'm going to move this C up to the numerator in order to change its exponent to positive. And I'm going to do the same thing to the Y. Okay? Now, let's simplify. What's numbers become? 4 over 9. In other words, I'm going to do these one at a time. I'm going to do the numbers, then I'm going to do the letter A, then I'm going to do the letter C, and then I'm going to do the letter Y. What's the net A that we have? And is it in the numerator or the denominator?
It's going to be in the numerator.
What's the exponent?
Squared.
Okay, how about C?
C to the 10th.
Numerator or denominator?
Numerator. Yep.
There's your answer, all positive exponents. Now, I actually could have done this a couple of different ways. I didn't have to do it this precise manner. I could wait until I get to the very end and then convert all my negative exponents to positive exponents. But sometimes it's just a little easier to do it early. Given how many negative exponents I had, It made the problem a little easier to do it that way.
Okay.
What else? In other words, these problems you're giving me are very easy. There are only two rules. Now, all that background noise I hear, is that coming from your phone or is that coming from your microphone on your computer?
I don't know.
There's our three rules. That's the only three we care about when we're doing any of these problems.
Okay.
Okay? What's the next one?
Parentheses.
M N squared.
I didn't hear what you said.
Parentheses. M N
Squared.
MN?
Yep.
Like that?
Yep.
Okay.
And
Parentheses.
I got a feeling we have... Say something. I'm gonna hang the phone up. If it doesn't work, I will call you right back. Say something again. Julie? Can you hear me? Okay, I will call you back. Okay. Yeah, you've got your speaker and microphone on because I can hear it. And it's causing a little bit of interference with my phone. But we can certainly make this work for 15 more minutes. Yeah, I'm not quite sure what's going on. I suspect you don't have your speakers turned up or something. Oh, I just heard a beep. Now I don't hear any of that background noise anymore. Okay. All right. So what was this problem? MN squared, end parentheses?
To the negative fourth.
Negative fourth exponent, okay.
Parentheses. 2m squared. And yep. To 0. Parentheses. 3m cubed. N to the fourth. And parentheses. Squared.
Simplify?
Yeah.
What's this all become?
1.
Uh-huh. Every number to the 0th power becomes 1. Even 0. Even 0 to the 0th power is equal to 1. So regardless of what m and n are, doesn't matter. This goes to 1. Okay, so that's the first thing we can do. Now, how do we handle that?
Hang on.
Oh, I know you're on my speakers now. Go ahead.
Sorry, what was the question?
What is this? I'm getting like a double reverberation here, so it's hard for me to understand what you're saying. What is that equal to, what I have squared there in the rectangle?
To the negative fourth. and to the second.
Negative
No,
1.
to negative 8.
Good. So that's that. And then what's this thing become?
9 to the 6 and to the 8.
Okay, now combine that and that. What do you get?
9 to the 6.
Hold on. We got that. We got that. Combine those.
Squared. And, no.
N to the 0,
Yep.
which is 1, which means that's our answer.
Okay.
Okay?
Yeah.
In other words, there's nothing about any of these that are anything but those 3 rules and the fact that that is equal to this. In other words, you have to know that also. But as long as you know the 3 rules of exponents and what a negative exponent means, I don't care how complicated or how many variables you put into it, these are easy. Just do it.
Okay.
Just do it variable by variable, one at a time.
Okay.
What else?
Mm-hmm.
We still have
Minutes. I'll give you your name and address, the credit card number I use. Esther, E-S-T-H-E-R.
So what I have is
Can't understand you. What?
S.
hang on.
Say again, Julie. X cubed plus 125?
Yeah.
What do we want to do? Factor that?
No, it can.
Yeah.
Okay. Well, we're looking at A cubed plus B cubed. First of all, you need to know how that factors.
We're supposed to count.
Okay.
Do you have that? Do you know what that is?
Mhm.
What is it? What's the linear term?
A cube.
Actually, always the linear term is the same sign as that. Always. In fact,
Okay.
let's go over these because this is going to make it much easier to memorize. If you have the difference of squares, that is A minus B times A plus B. If you have the difference of cubes, the first term is still a linear term, same sign as what I'm starting with. The second term is A squared opposite sign. And finally, when you have the sum of cubes, which is what we have here, the way I memorize it is this is the same sign as this. This linear term has to be A plus B. This looks the same as that, only opposite sign. So this must be A squared minus AB plus B squared.
So that's just an aside for your comment.
So you need to, first of all, memorize those 3 things. And now we have x cubed plus 125. Well, that fits this one right there. What's A? What's B?
You know what I mean? They were both.
A is X and B is 5.
Okay, what's this part over here going to be?
x squared minus 5x
Oh, okay. Okay.
plus 25.
Perfect. That's how you do it.
Oh, okay.
Okay? But notice what's happening here. I get a lot of students that memorize that backwards. In other words, they memorize it as a plus b times a minus b, which is clearly the same thing. But in terms of making it so that you can memorize all three, it's not the same thing at all. In other words, the key in memorizing all three of these is that this sign of the linear term is the same as that, that sign is the same as that, and that sign is the same as that. And then whatever the second term is, the sign is opposite. In other words, that's positive, that's negative, opposite. And if you memorize it that way, there's very little chance of making a mistake. And each one of them start out with a linear factor. All three of these are linear.
Alright.
What else, Julie?
Oh, well, this one I missed and it was kind of stupid. But it's 64x cubed minus 27.
64x cubed minus 27. Okay, you might not recognize that, but is that difference of perfect squares?
Probably.
No, that's not a perfect square, nor is that. Well, what's our other choices? Is it difference of perfect cubes?
Yes.
Yes, it is.
I'm going to do it.
Okay, so we know that difference of perfect cubes factors this way. No?
Yeah, it will be, but
How does it factor?
A minus b a squared minus
Plus.
no,
The sign's
plus
always opposite this sign, no matter
plus
what we're
b.
doing. And it's AB.
Okay.
And it's always plus on the third term. Okay? Notice that that's a square, a cubed right there. What is a? If this is a cubed, what is a?
No, I get it. Well,
Then a is
the little tiny part, the lower part, most of the tree is the upper part. So it's a small
hang on.
tree.
What's the cube root of this?
the cube root. Well, I know the square root is 8.
No, we're not dealing with square roots, though. We're dealing with cube roots. In other words,
I know.
we're looking at the cube root. So we need to take the cube root of that, which is 4x. What's the cube root of that?
3.
3, exactly. So there's your first term. Okay? Now, what's this part? Now that we know what a and b are, what's a squared?
Right.
16 plus, okay, 16x plus
16x squared. In other words, we have to square that term.
Plus, hang on,
0149.
12x
What's the third?
plus 9.
Good. And just for your curiosity, this never factors. No matter whether we're talking sum of cubes or difference of cubes. The quadratic that you get, don't spend any time at all trying to factor it. It will not factor.
Okay.
Okay? And never does it factor. If you start with difference of perfect cubes or sum of perfect cubes, you always end up with a quadratic term when you factor it. And I spent many an hour trying, wasting my time trying to factor that just in case it did, and it never does.
Okay.
Okay? All right. It's 5 o'clock. You good to go, or do you have any last questions?
No, I'm good.
Okay. Before we go, I'm just going to hang my phone up. I have a feeling I can hear you on your speakers. Let's just get to the bottom of this. Hold on. Oh, I'm already hanging my phone up.
Yeah.
Oh, we've been on for a while. We've been on speakers and microphone.
Yep.
I don't know what you did on your end, but whatever you did at some point, it caused your speaker and microphones to work.
Okay. I have no clue what I did either.
Okay. Julie, let's see, are we still going to meet on Wednesday?
Probably.
At 4:30?
Yep.
Okay, try to give me as much notice as you can, especially this week and next week, because I'm going to be jammed up. With finals coming up, everybody's going to want sessions. So if you can give me at least 4 hours notice, then that opens up a spot and I'll be able to put other people there.
Okay.
Okay? All right, Julie. Talk to you Wednesday. Bye-bye.
Bye-bye.